In this video, we're going to take a look at a very important application of the definite integral, which is area under a curve. So let's suppose that we have a function represented by this red curve, which is f of x, and we have this area bounded on the left by a, and bounded on the right by b, and bounded below by the x-axis. Okay, this is the x-axis. So this area, represented by the highlighted yellow, can be found by creating a definite integral. And so we want the definite integral from a to b, the lower bound at the bottom, the upper bound at the top, of the function f of x dx. So let's do an example. We want to find the area between the curve of x squared plus x plus 1 and the x-axis over the interval from 2 to 3. So go to Desmos, draw yourself a little graph based on what Desmos tells you, and you're going to get something that looks like this. It's a parabola, and we want to bound that parabola at 2 and 3. So here's, let's just say here's 2, and let's say here's 3. So the area that we're looking for is this, okay? It's bounded by the function on the top, the x-axis on the bottom, and 2 and 3. The integral that we will create will be the integral from 2 to 3 of x squared plus x plus 1 dx. And so we wanted to find the antiderivative. So that's going to be 1/3 x cubed plus 1/2 x squared plus x. And we're going to evaluate that from 2 to 3. And so at this point, you can go to Desmos. In Desmos, your antiderivative would be 1/3 x cubed plus 1/2 x squared plus x. And then you want to find f of 3 minus f of 2. And when you do that, you're going to get 9.83, rounded to the second decimal spot. And so just as we've always been doing, just do this part in Desmo, save yourself from doing all that arithmetic. All right, in the next example, let's find the area of 10 minus x, over the interval from 0 to 8. So once again, go into Desmos and see what the curve looks like. And then on your paper, just draw a little line. So it's going to look something like this. And so this is going to be 10 on the y-axis and 10 on the x-axis. And it's bounded by 0 and 8. So that means we're going to bound it at 0 and at 8. And so the area is going to be all of this area in here. That will be our area. And so the integral that we want to set up would be the integral from 0 to 8 of 10 minus x dx. And finding the antiderivative of that, we will have 10x minus 1/2 x squared evaluated from 0 to 8. So once again, in Desmos, capital F of x is 10x minus 1/2 x squared. And then you're going to find capital F of 8 minus capital F of 0, and that area should come out to be 48. All right, let's do one more with an exponential. So if you go into Desmos and you graph this exponential, you're going to get something that looks kind of like this. Exponentials kind of hug the x-axis, and then they start coming up and up and up and up and up and up like that. So there's typical exponential. And again, you just need a rough sketch of what's going on here. And we are being bounded by 0 and 1. So let's just say that 1 is here. And of course, 0 is right here. That means the area that we're looking for is this area in there. There's our area. So our integral is going to be the integral from 0 to 1 of e to the 3x dx. The antiderivative is 1/3 e to the 3x, evaluated from 0 to 1. So in Desmos, capital F of x is equal to 1/3 e to the 3x. And then all you have to do is find capital F of 1 minus capital F of 0. And that should come to be 6.36 approximately. So as long as the area is above the x-axis, as you can see in these three examples, it's a pretty simple matter of just setting up an integral. However, sometimes the area will be below the x-axis. And if the area is below the x-axis, we're going to get a negative area because our values are negative. The y values are negative below the x-axis. So we need to compensate for that by taking any area that is below the x-axis and simply taking the absolute value of it or negating it. So that can be shown in this first example. So if we graph this in Desmos, you will see that this parabola looks something like this. And it intersects here at 2 and here at 2. And again, you can get that from Desmos. But our bounds of integration are from -1 to 1. So that means we want to integrate from here at -1 to +1. Again, that's a -2 right there. So the area that we're looking at is this area in here, which is entirely below the x-axis. So what we're going to do is our area is going to be the negative of the integral from -1 to 1 of x squared minus 4 dx. So then we're going to have the negative of, so we have 1/3 x cubed minus 4x, evaluated from 1 to -1. And so then when you enter this into Desmos, you're going to have f of x is going to be equal to negative 1/3 x cubed minus 4x, which you could then just distribute that negative through and make it a negative 1/3 x cubed plus 4x. So take note, we're negating this integral, so we're negating the antiderivative, and the easiest way to do that with the fewest number of parentheses and everything is just distribute the negative through, making that negative and that positive. And so once you do that, then you can evaluate f of 1 minus f of -1, and you should get an area then of approximately 7.34. If your area comes up with a negative in front of it, you did something wrong. Chances are you just forgot to negate it, and the simplest thing to do, if you just simply forgot to negate it, would be to change the sign. And this last example, we have a situation where the graph is partially below the x-axis and partially above the x-axis. Okay, so again, you can go into Desmos and take a look at this. We're bounded from -2 to 2, and so -2 is going to be, let's say, right here, and +2 is right here. And so we have this area here, and we have, let's do it a different color, this area over here. Now, this area over above the x-axis is going to be a positive area, but this is going to be a negative area. So what we actually have to do here is to break this up into two integrals. And so we're going to find the blue area first. And so the blue area is going to be the integral of x cubed dx, and that goes from 0 to 2. Okay, so here's 0 right here. So I'm just doing the blue area. I'm going to even highlight the blue area. And that area then is going to be 1/4 x to the 4th evaluated from 0 to 2. And when you evaluate that, you're then going to do f of 2 minus f of 0, and you're going to get an area of 4. So that's your area of the blue area. The next thing that we want to do is create an integral for the yellow area. And that's going to be from -2 to 0. So the lower bound now is -2, the upper bound is 0. But it's the same function, x cubed dx. And one last thing we need to do is don't forget to make this then negative. Well, now finding the antiderivative is exactly the same. So the area is equal to negative of 1/4 x to the 4th, evaluated from -2 to 0, which is negative 1/4 x squared from -2 to 0. So when you go into Desmos and you let f of x now be negative 1/4 x to the 4th, and you do f of 0 minus f of -2, you should get another positive 4. And this, of course, is your yellow area under the curve. So we're negating the part that is under the curve. And now your total area then is sum of the blue area and the yellow area. So the total area is equal to 4 plus 4, or 8. All right, that's it for this video.